I would compare this to the arrival of the World Wide Web in the early 1990s in terms of its enabling capability. Of course, we'll see whether that prediction holds up, but it's a very powerful step.
The internet as a network, at its fundamental layer, has no security in it. So you cannot really identify when you receive some information across the network that it came from the place that you really thought it came from. So this has a couple of problems. There's always the potential that somebody who tries to go to their bank website will be sent somewhere else, and you try and put controls around that to make that less likely. The trouble is, for an end user, the question of whether you're seeing authentic data is a complex technical issue, and end users need tools to be able to identify whether it's true or not. The tools, in many cases, don't give 100% assurance. So what we're trying to do is add some additional tools, some additional framework to allow that end user to have more confidence in the place they're going being authentic. So what we have is a collaboration between three entities who are all together involved in making the root zone of the DNS, which is VeriSign, the US Department of Commerce, and ICANN. And what we did is we formed a design team to try and build a solution that we thought preserved that structure with those three organizations, but added the security aspects in. And then what we've done since then in the last year is a pretty wide technical consultation around the world, talking to protocol experts and operators of networks and DNS services to try and get their feedback on what our design was and to try and find out whether there are aspects of this that might cause problems for anybody. The feedback we've got has been overwhelmingly positive. I think the general summary I would give you is that people are very keen for the route to be signed, and they're very happy with the way we're doing it.
It's a carefully scripted ceremony for maximum transparency. Each step is carefully lined out. We have a room full of, about 30, 35 people that will be watching every part of this step. Some will be participating in this process as well. The people will be brought into the room. Filming begins. The whole ceremony is filmed. It's not anything where people hum or have some sort of strange ritual or anything like that. I think sometimes it gets misunderstood. It's just a very formal process. Then there'll be a process of actually pulling out equipment from various safes.
These are the Class 5, GSA Class 5 safes that are used by the federal government. They do have seismic sensors, and they also have door sensors, which would basically lock us out when the alarm systems are turned on. You can't leave the room if this door is not closed and locked.
There's alarm systems in every part of this facility so that any unauthorized personnel immediately set off alarms and stuff. Equipment's pulled out. We go through the steps and we generate this key inside this cryptographic box. And then once that key is generated, we'll have printouts with what is called a hash of the key, a shorthand version, not the full key, which is a 204-8-bit key, but not a full, but a short version of that we'll hand out to the participants, and they'll be able to say, we were there, we saw it generated. Not only that, we saw that there were no cards up anyone's sleeves. We saw the process, we saw it on the monitors. We attested this being generated properly. In order to engender trust in this process, we've made sure to bring in, we've got at least 21 trusted community representatives, what we call it. For this particular meeting, we'll have 14 of them. They're involved in the process in the sense that they will have control over various smart cards that is generated in this process that enable this cryptographic device to operate. So once this key is generated, not only were they part of the generation, but now every time we want to use this, ICANN by itself cannot use this. We need the involvement of the internet community. There are two sets of people. There are what we call crypto officers and recovery key shareholders. In the highly unlikely event that we lose both East Coast and West Coast facilities, ICANN has built two sets, similar level of security and safety and backups. If they all go away, we need some way to recover. So what these recovery key shareholders hold is a smart card, which is a piece of a key, but not the root key, but piece of a key used to encrypt the key in tamper-evident bags, standard tamper-evident bags that banks use, and they're responsible for those. So, and we've set it up so that we need a minimum of 5 of those people to come together to recreate that encryption key. The crypto officers, on the other hand, we're going to give them physical keys to a safe deposit box that we have built inside one of these two safes that actually has the smart cards in there. And you might ask, well, why aren't we giving them the cards? This system has to operate. It cannot fail. So if we have a 9/11 situation or something where these people cannot travel here, we have to be able to get at these keys. So in the extreme case where we need to recover this thing, we can drill.
So the idea is just to keep it as safe as we possibly can and provide assurance that it hasn't been tampered with, that nobody has had access to it since the last authorized event where the key was brought out to be used. So that's why we're very careful taking it out, and we're very careful storing it, and we make sure that that whole time between people being in the room, we have a complete audit trail with surveillance and everything else to be able to demonstrate to the satisfaction of anybody who cares to ask the question, the secret key is safe.
More has happened here today than it meets the eye. An infrastructure has been created for a hierarchical security system, which can be purposed and repurposed in a number of different ways. And so I would predict that although we started out putting this system together to assure that the domain name lookups return valid internet addresses, that in the long run this hierarchical structure of trust will be applied to a number of other functions that require strong authentication. And so you will have seen a new major milestone in the internet story.
Generating the 204-bit RSA key pair. Okay.